Section 5.3, two-way tables and probability. How can you construct and interpret a two-way table? So a two-way table displays the same information as in a Venn diagram, as in you have two different categories and then you have an overlap. So this Venn diagram shows the results of a survey in which 80 students were asked whether they play a musical instrument and whether they speak a foreign language. Use the Venn diagram to complete the two-way table, then use the table to answer each question. So looking at this, it's basically telling us use this Venn diagram to fill out the total, or not the total, the table. And one thing that I could start off easily is, well, whatever. Let's just go here. Speak a foreign language and play an instrument. So this is for students who do both. So where is that on this Venn diagram? 9 who don't do anything, the 25 who play an instrument, the 30 who speak a foreign language, or the 16 who do both. And this is under both categories. We would go with 16 here. Now we want those who do not play an instrument, so we don't want it to be in this circle of the Venn diagram, but we do want them to speak a foreign language, so that's 30. Sorry, that's ugly. So you have 16 and 30 here, and to get the total, you just add them up. So I have 46 here. Play an instrument but do not speak a foreign language. So play an instrument but no foreign language. And do not play an instrument, so outside of this circle and outside of this circle, or 9. So 25 plus 9, there are 34 students who do not speak a foreign language. There are 46 students who do speak a foreign language. The number of students that play an instrument, 25 plus 16, that's 41. And 30 plus 9, there are 39 students who do not play an instrument. Why didn't I finish that? 41. And the total, it says there are a survey of 80 students, or you add them together and you get 80. So now let's see. Using this table, so your table will not move, but mine will because I'm scrolling. How many students play an instrument? Well, how many students play an instrument? Does it matter if they speak a foreign language? No, it does not matter at all. We don't really care about this. We just want to know how many play an instrument. The answer is 41. How many students speak a foreign language? How many speak a foreign language? Right here, 46. Sorry. So there are 46 students who speak a foreign language. So I'll just copy this real quick. Actually, I should scroll down a little bit. 16, 30, 9, and 25. To erase all that. How many students speak a foreign language? So it was the foreign language category, which is 46. There you go. How many students play an instrument and speak a foreign language? 16. So, this is just finding the category in the table, which is just being a detail-oriented, being kind of careful and make sure you discern which is the right category moving forward. In exploration 1, one student is selected at random from the 80 students who took the survey. Find the probability that the student plays an instrument. So how many students play an instrument in total? 41. And how many students are there in total? 80. So the probability that a student plays an instrument out of all students is 41 over 80. 41 out of 80. And go ahead and tap that into your calculator, find a decimal and a percent. So again, these are just like, putting them whatever number this is, you find the probability by putting it over the total number of students, and so that's just over 80. Moving on. Let's see. So in these for these definitions, the only difference in joint frequency and joint relative frequency is this is a percent, and this is just like the number. So for instance, earlier we had a table that went something like 16, 25, I think it was 30, then 9. So the joint frequencies are just, these are it. These are all the joint frequencies. The marginal frequency, think about what the margins are on like a piece of paper. The margins are the edges. So the margins are the totals, and I'm actually going to put them in a different color to differentiate. Maybe green is a little harsh, it's a little bright. Let's go purple. So the margins are over here. So the marginal frequency would be like 41, 39, 34, and 46. The joint frequencies are just these blue ones. The joint relative frequencies, relative means like compared to everything else. So let's make this a dark green so it's not so harsh. So I will do joint relative frequencies in green. So you would say something like 16 over 80. That would be a joint relative frequency, or 25 over 80. So the only difference between, so joint and marginal frequencies is just like the flat out numbers, like these are results. But the relative frequencies are percents of the total. Percents over, so that would be, the marginal relative frequency would be, let's say, like a teal-ish color. So it would be 41 out of 80, and again, this is for marginal relative frequency. So relative means it's a percent, because your relative means you're comparing it to everything else. And then a conditional relative frequency is for when you have you're comparing the joint relative frequency or the joint frequency to the marginal. So let's do this in a different color. And so that's like saying instead of comparing it to all 80 students, I just want to compare it to the total number of, whatever category that was. I can't remember what it was. Like instrument playing, I think. So you would say, what is the chances that a student who plays an instrument also speaks a foreign language? Then this would be 16 out of 41, because I only care about this category. Okay, if you have any questions, make sure you let me know. Otherwise, let's just clear everything. This is just saying, all this is just to say what I had just said. Joint relative frequency is the ratio that is not in the total row or the total column, so it's everything inside the table that's not in the totals. A marginal relative frequency is when you add up the relative frequencies in a row or column. A conditional relative frequency is when you compare anything in the table to one of the total, whether that's in the row or the column or whatever. So use this information, you're basically just using addition and subtraction on almost all these to like think about, how can I construct, what is a valid way to do this? Here I will break down the categories for you, but I will not be filling it in. Survey was taken of 100 families with one child and 86 families with 2 or more children. Of those, 94 of the families with one child and 60 of the families with 2 or more children were saving for college. Organize these results in a two-way table, then find and interpret the marginal frequencies. So marginal frequencies is saying find and interpret the totals. The margins are like, the totals on the right side and on the bottom. So we have two categories here. Families with one child and two or more children. And then the other category is saving for college. And then if you're saving for college, what's the other thing? You are not saving for college. So let's make a table for this real quick and split up our categories. So you have families with one child, and families with 2+. And then you have saving for college, and not saving. So read this very carefully to figure out what numbers go where. And then it says find and interpret the marginal frequencies. So again, the marginal frequencies are the totals here and there. And then interpret them, which means, after you find them, say something about it. Like, oh, this many families are doing this, or this many families are doing that. Okay, so that's the lesson. I would say the most important thing is to be a very discerning reader, to kind of like categorize and read very carefully to make sure you know like what category they're asking you about. Like, what is the probability that a randomly selected parent? So should you be looking in, if it's asking you about parents that did eliminate, so this is eliminate and this is not eliminate, then which category should you be looking at? And you should only be looking at the parents category for part A. What is the probability the randomly selected student did not want to eliminate the class? So now this is saying randomly selected student, so you should be looking at this total and not as a whole 100%. Like it says, oh, randomly selected student. And I guess I'll just do one, so just for an example. What is probability the randomly selected student did not want to eliminate? So no elimination, 0.15 out of all students over 0.23. And then, you find a percent there, or a decimal there, and turn it into a percent. So let me know if you have any questions. I'll have the answers in my book, and any explanations or clarifications you need, make sure you ask a neighbor or let me know.